Hey everyone, so let's understand the metrics for evaluating the results of generative AI when you are doing the software testing tasks. Now these metrics are really important to see the effectiveness of the results of generative AI. So metrics help you to evaluate, first thing, whenever you are prompting, what is the efficiency and quality of that prompt, what sort of results it's providing. So the metrics that we are going to discuss in this tutorial will help you to see whether your prompt is good enough, providing you the accurate and better results, or it's just an average or poor prompt. So a couple of metrics we are going to discuss here are the accuracy, precision, recall, relevance and context fit, diversity, execution success rate, and time efficiency. Now all of these are very important from the software testing and test automation point of view when you are using generative AI in any of these tasks. So let's understand what exactly accuracy is all about. So accuracy measures the overall correctness of the generated output against expert written test cases. Whatever requirement, expert written requirement, whatever format you have, whatever quality of test cases you have, or established standards of documentation you have for the testing team, is the generated output by the generative AI for your testing tasks, is it of similar quality, better quality, or bad quality? For example, if we talk about the test case generation in generative AI model, if you ask to generate the test case for a calculator app, just for example, just assume. So if we say high accuracy of the test cases that get generated, so generated test cases correctly identify the expected output for basic addition, subtraction, multiplication, or division operation. But if we say low accuracy, if the output says, or the test cases that are generated by the generative AI says that dividing by 0 is also a valid operation, then obviously you know that model, that generative AI model, is of low accuracy. So this is what accuracy metric is all about. If you provide a user story and you ask to generate the test case in the context of your project and user story, is it covering all the aspects properly, or there is some other model which is providing you better results? So in that case, you know the accuracy of the model that you are trying to get the test cases from is low, and the model that is providing you better results is of high accuracy. So that's what the accuracy is all about. Then we have the precision metric. So precision evaluates the correctness of the generated output with respect to specific objective. How correct the output is with respect to the specific objective, focusing on the proportion of positive identifications that were actually correct. So whatever has been suggested, how much percentage or how much of that is correct by the generative AI. For example, if we say defect prediction in the Gen AI model, which predicts the module, the code module where the defects are likely to be there. Okay, so in this case, if we talk about precision, the model will be high precision if model says, okay, in module A and B there is high chance of defects, and you actually go and see that in yes, both model A and B there were defects. So you know that the precision of this identification is high of that model. If we say low precision, the model says that in module A, B, C, D there will be defects, but you actually go ahead and figure out that only module A has defect, and all three module that was suggested by the generative AI that there were defect, actually there was no defect. So there are a lot of false positive in this case. Three modules didn't have any defect, but actually the model suggested. So this is how you will measure the precision of the generative AI model. Then we have the recall. The recall metric measures how diverse and comprehensive the generated samples are compared to true data set. So what is the coverage? What is the diverse range of coverage that you get in your answers? For example, if I say generate the test scenario or identify the test scenario, the Gen AI model reviews requirement and lists the necessary test scenario. So I provided the requirements, I provided the user stories, and asked to generate all the test scenarios for those user stories. So if we say high recall will be there when the list of your test scenarios includes the positive, negative, boundary conditions, performance testing, security testing. So you'll see that it's providing you diverse and comprehensive set of the test scenario in that case. But if you provide the user story and the model only generates the positive scenario, the happy path scenario, then you know that it's not providing you diverse and comprehensive test scenarios. So in that case, you know that the model is not providing you better outcome. So this metric will help you to check whether the output is diverse and comprehensive for any of the scenario that you are using GenAI for. Then we have the relevance and contextual fit. So relevance and contextual fit determines whether the generated output is applicable and appropriate for the given context and task. For a context, is the output relevant? Is it fit or not? This becomes crucial in GenAI for avoiding hallucinations. For example, if you have the test reporting scenario, the GenAI model summarizes daily test execution results. If we talk about the relevance and contextual fit for the test reporting, high relevance is there if the summary that is generated by the GenAI model focuses on open defect, pass, fail, critical blockers in the current sprint. But if the model suggests the defects that were found in the previous sprint or all the previous sprints and not specifically focusing on the current sprint, then you know that the relevance is less in that case. It is not relevant and not contextually fit. So that's the relevance and contextual fit metric. Then we have the diversity of the generative AI output. So diversity of the generative AI output ensures a wide range of inputs and scenarios are covered. So how diverse the output is. Avoiding the repetition. Lack of diversity leads to model bias. For example, if we say user persona generation by the GenAI, you are trying to create the test data for user persona for usability testing. Now, high diversity output by the GenAI will be that the persona covers different ages, technical abilities, language, and accessibility need. So that's the data that you will see that it's a high diverse data. But low diversity, all personas that are generated by the GenAI or all the test data generated by the GenAI actually describes the same type of power user with perfect vision and technical expertise. If this type of data is generated, then you know that the model is biased and doesn't generate the diverse test data that you need. So that's the diversity of the generative AI output. The next metric is the execution success rate. Very, very important for test automation scripts that you generate. So execution success rate measures the proportion of the test cases that are generated that can be executed successfully without any issues. Okay, so generative AI suggested something and you went ahead, say for example an automation script in Selenium, and you went ahead straight away, copied and pasted and executed and went through or executed successfully without any modification. So this is execution success rate. So ESR is a key measure of the quality and usability of the AI's output from an automation perspective. A high ESR means less time spent in debugging that AI generated code. So if you are generating the test cases, the code from the generative AI, and you are spending a lot more time in debugging, you are actually getting a lot of overhead because you could have just written the script yourself, the test cases yourself. So the execution success rate becomes really important in that case. So execution success rate, how you can calculate? Number of successfully executed scripts. Say for example, you got 100 scripts that are generated by the generative AI, 100 Selenium scripts, and 95 of them executed successfully. So number of the executed successfully is 95 out of 100 generated script multiplied by 100. So the execution success rate is 95% in that case. This is really important for any scenario in generative AI when you are using Gen AI into software testing, because the output should be usable and the success rate should be more. Otherwise, lot of time goes into debugging and actually Gen AI will be an overhead in that case. Then we have the time efficiency. So time efficiency evaluates the time saved compared to manual test efforts. This is crucial key performance indicator KPI for demonstrating a clear return on investment for AI integration, for Gen AI integration. So how much time efficiency you are getting after integrating the Gen AI into your project. What's the formula of the time efficiency? Time without AI, whatever time the person is spending without any AI tool, minus the time with AI tool, when the same task is done with the AI tool, divided by time without AI and multiplied by 100. It's calculated in percentage. So for example, if tester used to take 8 hours to write a set of regression test cases for a particular functionality, and generative AI generates equivalent set of test cases in 2 hours, which includes any modification correction in those test cases. So say for example, 2 hours is the time that you as a tester spent in generating similar quality of test cases using generative AI that you used to take 8 hours to generate the test cases without Gen AI. So the time efficiency in that case will be 8 minus 2 divided by 8 multiplied by 100, which is 75%. Okay. So the time without Gen AI minus the time with Gen AI divided by the time without Gen AI into 100 represented in percentage, which is 75%. So that's the time efficiency you will get. Now with this, if say for example you are generating the test case very quickly, but you spend a lot of time debugging, right? Then in that case you won't get good time efficiency, and you know that the model is not providing you of much value. Then we have the task specific metrics and evaluation, wherein the whatever metrics we have discussed, there will be additional general quality and efficiency metrics or task specific metrics which can be tailored to evaluate how effectively generative AI supports highly specific test activities. For example, testers can evaluate these metrics using a combination of manual and automation approaches. Whatever task specific metrics you can use, you can either use the manual review or automated evaluation. For example, human testers assess the AI output against requirements or predefined criteria. That's another task specific metric. Using manual reviews, you can assess the creativity of the generated edge cases, whether they are good, bad. Then you have the automated evaluation that you can use as well, along with the other metrics that we have discussed, comparing the LLM output against predefined reference or expected output using script or tools. So you can have the automated check on the outcome as well. Now, because the Gen AI output is non-deterministic, which means that for the same prompt you can get different results each time, the metrics must be based on statistically relevant data. When we say relevant data, is the outcome relevant? Is the outcome task specific and usable? That should be the criteria, not the exact outcome you should be checking. So that becomes another important criteria. Now with this non-deterministic nature, you should be running the evaluation multiple times across a sufficient data set, which ensures reliable conclusion about the AI's performance. So task specific metrics is more of what as an end user you see manually what the output is being generated, whether it is of good quality, usable, creativity is there, edge cases are there. In the automated evaluation, you can put some tools to automatically check the quality of the code and all of that detail. Okay, so that's more in the metric section, the task specific metrics and evaluation. So these are some of the key metrics that are really important for you to see the effectiveness of generative AI into software testing tasks. And as a tester, test lead, test manager, or whosoever is managing the overall testing activities into the project, use these metrics religiously to get the best of generative AI capability into your projects. Thank you. I'll see you in the next tutorial.